Hello everyone, welcome to Business School 101. Imagine you're a business analyst trying to understand why sales spike during certain months, or a product manager wondering whether customer satisfaction is tied to delivery speed. These questions lead us to one of the most powerful concepts in data analysis, correlation. So what exactly is correlation in business analytics? How does a correlation coefficient help us measure the strength and direction of that relationship? What visualization tools can we use to spot these patterns? And how can we tell whether two things are simply moving together, or if one is truly causing the other? In this video, I will discuss these questions with you. Section 1. What is correlation? In data science, correlation is a way to describe how two variables move in relation to one another. A positive correlation means that as one variable increases, the other tends to increase too. A negative correlation means that when one goes up, the other goes down. For instance, if customers with higher satisfaction scores also tend to visit your website more frequently, that's a positive correlation. If sales go down as product returns go up, that's a negative correlation. Section 2. Scatter plots and line charts. To uncover meaningful patterns in data, we rely on visual tools. One of the most effective tools for exploring relationships between two numeric variables is the scatter plot. Imagine analyzing customer service performance. You place response time on the x-axis and customer satisfaction scores on the y-axis. Each dot on the chart represents a customer. As these dots begin to cluster or align in a certain direction, you start to see whether faster response times are associated with happier customers. That's correlation in action, made visible. Next, we have the line chart, perfect for examining how data evolves over time. Whether you're tracking monthly revenue, daily website visits, or product returns, a line chart helps you spot long-term trends. A line steadily climbing might suggest growth, a sharp dip could indicate a problem. And a jagged line? That signals volatility, fluctuations you may need to investigate further. Section 3. Correlation coefficients. Visualizations are powerful, but sometimes we need more than just a picture, we need precision. That's where correlation coefficients come into play. These are numerical values that help us measure the strength and direction of the relationship between two variables. The coefficient, often denoted as R, ranges from -1 to +1. If the number is close to +1, it means there's a strong positive correlation. In business terms, this could mean as one factor increases, so does the other. For example, as advertising spending goes up, sales revenue tends to rise, a classic positive correlation. A value close to -1 indicates a strong negative correlation. Imagine a company's customer complaints compared to customer satisfaction scores. As complaints increase, satisfaction typically goes down. If the correlation coefficient is around 0, it means there's no meaningful relationship between the variables. For instance, you might find no correlation between a customer's shoe size and their likelihood to purchase a premium subscription. Nowadays, most spreadsheet tools can calculate these for you, no manual math required. Section 4. Correlation heat maps. When you want to assess many variables at once, use a correlation heat map. It's a grid where each cell shows the correlation between two variables, color-coded for easy reading. For example, if education and income are strongly related, that box might be dark red. If TV time and education show a negative correlation, the color might be blue. It's a simple way to spot patterns across an entire dataset. Section 5. Correlation versus causation. Now let's talk about one of the most important principles in data analysis, and one of the most misunderstood: correlation is not causation. Just because two variables move together doesn't mean that one is causing the other. Here's a simple example. Imagine it's summer. As temperatures rise, more people buy ice cream. At the same time, fewer people buy umbrellas. After all, it doesn't rain as much. You'll notice a correlation: when ice cream sales go up, umbrella sales go down. But does buying more ice cream cause people to buy fewer umbrellas? Of course not. The real cause behind both is the hot weather. The lesson here is to think critically. Correlation tells you there's a relationship, it's a clue, not a conclusion. Before you act, ask deeper questions. What's the underlying factor? Could another variable be influencing both outcomes? Is there evidence that one variable actually causes the other? Section 6. Conclusion. To wrap up, correlation is a way to describe how two variables move in relation to one another. Whether you're improving customer experience, optimizing ad spend, or forecasting demand, understanding correlation can provide a competitive edge. But remember to stay critical. Use scatter plots, line charts, heat maps, and coefficients. Alright, that's all for today's topic. If you have any questions regarding this video, please leave your thoughts in a comment below. I hope you found this video helpful, and if you did, make sure to give it a thumbs up and subscribe to my channel. Thanks for watching, and I'll see you next time.